Welcome to Ask and Learn.
Hello and welcome. We are looking at Chapter 5, Section 4, Problem 21. We're asked to prove the algorithm in Exercise 7. So real quickly, let me copy that down. It's the product where n is a positive integer and x is an integer. If n equals 1, then we're returning x, else we're returning n minus 1. Oops, sorry. Back up real quick. The product of n minus 1 and x plus x. So we want to prove this using induction. So the first step with proving an induction is you need to prove the base case. In this case, it's n equals 1. So we want to prove that um, that product 1x equals x. So um, product 1x by definition is x. And we know that 1 times x is x as well. So that was pretty trivial. Usually the base case is pretty trivial. The second step, uh, after we have the base case, we want to show that the following statement is true. So if the product of, this time we'll do it a little differently than I usually do. So n minus 1 x equals, we'll just say x times n minus 1. Then the product of nx equals n times x. So the key to the second step of induction is we want to show that what the previous step leads to the next step. So we get to take this for granted, and we need to use logical steps to get to this. So we can say assume that product of n minus 1 and x equals x times n minus 1. So we get to just start by assuming that's true. Now we need to figure out how can we get to here. How can we get to here? So what we could do is we could, if you look, this right-hand side is equivalent to xn minus x. So I could get the right-hand side to match this right-hand side if I subtract x from both sides. So we'll say something like, then, we can always spice it up and say then clearly, just so we make anyone reading it feel like they're dumb if they don't get the next step. So we're subtracting x from both sides, and we get, sorry, we want to add x to both sides, because that gets me from here to here. Remember, my goal is to start from here and get to here. So it is subtracted by x. So to make it look like this, I need to add x to both sides. All right, so that gives me just xn over here, which means I'm really close. I just need to basically rewrite this left-hand side, and I'm done. So I'm going to kind of work backwards here. We're going to look at I want to show that this is the same as product and x. So let's look at what exactly, if I break apart product and x, what does it become? We know product and x, and then we can say, I keep forgetting to add this. Let me add this in here because this wasn't always true. We know for n greater than and just greater than our base case, which it looks like our base case was 1. So for n greater than 1, that product of nx equals, and then we can just use the definition of our procedure. So it's product n minus 1 x plus x. And then we're done because we've shown that, here's the chain of reasoning here. We've shown that this is equal to this. And so if that's true, then this is equal to this, which is exactly what I wanted to reach. And all I did was start with my inductive step there. So I can say as wanted. Then our proof is done.